Shut up! You never replied to my text. So you decided it's completely not. Because this could get pretty ghetto if I have to like help transport this couch on my boat. so I'm gonna attach the boat to the back of my car, put a couch on top of the boat, strap the couch to the boat. No, not the funniest thing.
No, if you're driving down the road and you saw that.
There's funnier things.
Oh, yeah, of course there are.
I mean, that's not the funniest thing.
Okay, yeah, a funny thing.
I mean, I don't know if that's much funnier than the other day when one of the pieces of wood we needed for the deck on the boat was too big to fit into my car. And we didn't have anything to actually strap it down to the roof of the car. So we just used our arms and just held it on the roof of the car. But
Serious?
yeah, Largen's arm, because he had surgery on his arm, so he couldn't use his right arm to lift it high enough. So he drove, and Largen can't drive. So he had his arm.
Like, are you talking ability to drive, or
shouldn't, as in the law doesn't want him to?
Yeah, no, the law is okay with him driving, but everybody else is not.
Okay.
Yeah.
I can see why you would.
Yeah, but he had to drive because the arm that we required him to hold the, and then.
Sit backwards and see it
Yeah.
well.
But then I don't think I broke my wrist. It's it's more just sore than
Something sticking on there.
Yeah. But he let go of it at some point, and the wind caught it. So I basically held. This is, I don't know, a 6 foot long by 4 foot wide board, 3/4 inch plywood, and the wind caught it. So I'm holding it like it's flying up in the air like this, and then it turned. No, it turned that way. That's right. Yeah. So, and I didn't let go.
How did you hold on?
I have no idea.
Come on, your wrist is more important than all the cars behind you.
So I told him to slow down, but he started flipping out, and the thing landed. And he grabbed back on.
Axon won't be here today. He told me to tell you that he already finished the chat server.
Okay. That's why he's not here. So we should have a quiz. Is that what we're saying?
No, what we need to have is the quiz. Question to be: did you finish the chat server? So we can't say no.
It doesn't make any sense.
Oh, that's good. That's good.
That's a good one. All right. So after class last time, we installed. Here, let me show you. Telnet, because remember we were trying to test it at the very end of class.
So what do we have to do?
Sudo apt-get install telnet.
You can install stuff on this account on our computer.
Yeah.
I didn't know.
That's cool.
So then we have a telnet client,
Packaged
which then allows us to go back and actually run our server. So I'll just launch the server again. So this is the exact same server we had last time with listening misspelled. And now we should be able to actually telnet to localhost port 3000, and it connects. It dies immediately, but we come back over here, we see that client connected. So our server was able to accept an incoming connection. Make sense?
That didn't work for me. It says unable to locate package telnet.
Probably want to spell telnet correctly.
It is. Yeah.
Try doing a apt-get update, sudo apt-get update. We must not have that pre-cached.
A lot of things, 9 bad screens. That must be good.
make sure you get your, before you actually test it, get your socket server running again. Yay, nay, maybe,
It's still loading.
hooray. Okay, so let's go back into our code then and review what we did. So we decided what we were going to listen on port 3000. We created our structure for our socket address. We set it to AF INET for internet connections, not AF Unix. This converted our port into the correct format for our for this struct. Same thing for our internet address. So this was this allows us to have incoming connections on any of our listening devices. So if you're on a machine that has a wired network cable as well as 2 Wi-Fi connections, for instance, it'll take incoming connections from any of those. So that's all just setup stuff. Then we create our file descriptor for our socket. It's going to be a INET socket of type sockstream. And we put in 0 there for the default. And then we bind it to the address. So we pass in our file descriptor for the socket, give it the pointer version of the address of name, where name is our socket address. And this was the thing we talked about last time, where by default structs are passed by value. That's why we needed to grab the address of that struct and then cast it back to a pointer in order for it to properly get accepted by the accept from socket.h. Size of name, this is the number of bytes that that structure has in it. All right. Then we're going to print out listening. Then we're going to go ahead and get our client FD. So this is when a client when this accepts, so this blocks. So when we start this guy up, it says listening, and here we can go ahead and fix it. Listening is 5 ends. At least 5 ends. Did that guy ever contact you, by the way?
He did.
Okay.
Actually, he apologized for.
Okay, so you're good?
Yeah,
You're talking or whatever?
Yeah, meet over coffee tomorrow.
All right.
Hopefully he'd like to.
All right, let me know. All right, so we're listening. This blocks right here. So we are going to indefinitely wait for an incoming connection. The connection is going to be over this socket. Here's the socket address crap again, size of, blah, blah, blah. And then as soon as we get an incoming connection, we just print out client connected. All right, so this is where we're currently sitting, and then the proof of blocking is right here. If I go ahead and just run this, that's blocking, although I need to recompile if you want the 2 ends to go down to 1 end. So that's blocking because it's sitting there waiting on that 1 line of code for me to connect. As soon as I go in and I telnet to localhost at port 3000, that line is able to finish. So now it's no longer blocking and it says client connected. We should now have the ability to write back out to the client using our standard I/O, universal I/O stuff. So I'm going to go back here to one of our early things. Oh, do we overwrite the... Actually, I think we have. We kept some of our write stuff. Oh, that was buff size of 1. We'll just rewrite everything. All right, so we're going to give ourselves a function that allows us to write to a particular output device. So that's going to be, I think, helpful for us. So we'll go ahead and say void write, and this guy will take in an int fd, that is the dude we're writing to. And then it's going to take in a message that we want to write. So char pointer message. All right. And remember, we had all that buffer size stuff, things like that. So what we want to do is we want to go ahead and, here, I'll bring up our copy reverse again so you can see, remember how this works. So in this example, this is when we were reversing a file. Remember, we were reading 1 byte at a time, which from our midterm we decided that was stupid. But this will at least give us our stuff. And we already have an open descriptor. That's our file descriptor that came from our connected client on the socket. So this guy is from this file that we were reading from. That's where all this create stuff is there. All right. So now, here is the array that we would be using to store our answer. This guy's going to be coming in as a char pointer to our function. So when we write something out, we're writing to a file descriptor, we're writing our answer, and we're writing a maximum size that we can write at a time. That's our buff size. Okay, and we just so happen to have our answer filled up with that. But we're going to set things up as strings to try to write. So we're going to write to that. So let me show you here. So and right. Oh, that's the wrong one. This should be. Let's look up our HDR thing we had in here. All right, so in standard io.h, that's our IO stuff that we're going to need. Have we brought that into our socket thing? I don't remember if we have. Yep, we have it. All right. So let's go into bash here. So what we want to do here is we want to write back to our, actually before we write this generic function, let's just go ahead and write a, just spit something back to our client. We have the file descriptor for our client right here, client FD. So we're printing locally that client was connected. So let's go ahead and do a write. Oh, that's interesting. Oh, that's my local function. That's why it looks that way. Let me take this function out of here just for a moment. So we're going to write to client FD. What we're going to write is hello and size 5, just for the sake of argument. Okay, so we're going to go ahead and recompile this now. Oh, that's just the warning. We're fine there. So our server is listening again. Go ahead and telnet. Did we get our telnet localhost space, whatever the port number you chose is? Yeah, and then go back to the other screen. You should see client connected.
Okay.
All right. We might need to do a flush. So when we write over C write to socket example, we might have to flush after it. Sometimes when you write something to a an open socket, if you don't what's called flush the socket, it doesn't come out the other end, which I guess that's kind of just as bad as some of the other stuff, but a truth nonetheless. All right, let's see here. Ooh. They didn't seem to do it. They didn't. Oh, they read it in there. Okay. Yeah, so they're writing the same way we are. All right, so let's just do a flush on that. I think it's just flush client FD. But let's check that over here.
At flush.
Oh, but that one's a file, not a file descriptor. Let me try to do a \n on that. Oh, I'm still doing that. Oh, it's not even connecting now.
Save it.
I thought I did. Still didn't read over here. I'm wondering if Telnet will... See, Telnet's a pretty open protocol, so we should just be able to write anything to Telnet and it should output. This is our file descriptor for the dude that was connected. Suppose we can do an F write. Oh, see, that's all over files. POSIX, write to FD. Maybe it doesn't like the way we created that char pointer for our string. Let's give that a shot. We should be able to, with that, just to give it a char array. Actually, it's going to be char buffer of size, I don't know, say 5. And then we should be able to say buffer is equal to hello. And then let's try writing buffer. Of size 5. Still didn't output. It's the same page we were just on. I guess we can look at standard template library to use C strings, but I'd rather just use plain Jane. Well, let's go back to this then. Actually, we have it down here. We'll use their file IO example. Let me just test it this way. I'm almost positive that I'm doing that right. Could just be a Telnet issue. Let me do, there's buffer, so I'm just going to do printf. %s buffer. Oh, we might need to do a \0. Let's see if this works. Yeah, see, it didn't even write locally. Okay, that's actually a good thing. Okay, \0 I think is the universal end of line character. it doesn't like. Okay, yeah, so it likes the char pointer then for that. Okay, there's the hello. So that means I should now be able to do a write to client FD buffer, comma, size of buffer. And now Telnet should be able to interpret the carriage return because \0 is how end of string was represented in original C before the standard template library was introduced with something called C strings.
Is that anything like G strings?
Nowhere, not even close. Totally different thing. Okay, that should be good. Still not.
If it's continually listening, how do you break out of it? I'm assuming
It's not continuing listening. It listens once until it gets an incoming connection and it's over.
I was assuming it's a keyboard shortcut.
Oh, I just keep pressing up. Up arrow.
No. Where it says listening and then the caret C up a little higher.
Yeah.
It's just Control C, isn't
But I mean, oh, you talking about if it's sitting here like that and I want to
Yeah.
kill it? Yeah, just hit Control C.
Control C.
All right. So it's definitely writing. So the is Telnet just not reading from it? Is it ending before POSIX write string to I think this is a Telnet issue, and we could just write our own client application. Yeah, I think we're writing correctly. All right, so let's steal their because we're going to need a client for this anyways. All right, so let's write our client application. I think it's just Telnet that's not automatically reading from the open socket because it's dying almost instantaneously. Here. All right, so I'm going to start with our, actually let's go ahead and rename this guy. We're going to call this guy ChatServer. And then we're going to duplicate this guy. And we're going to call him Chat Client. All right. So chat client's going to work the same way, except we are not calling accept on this. We're going to open up a connection. So we'll do our exact same thing we did before for establishing our socket stuff. And then we're going to call the connect back here. So we had that chart last time. Our sockets, we'll do man connect. This initiates a connection on a socket. Actually, let's just look at the top level. So we give it the socket FD, the address, and then the length of the address. So the exact same thing we did for the accept. So let's just prove that that's working. So come to our chat client. We'll set up our socket the same way we did before. We'll still bind, except we won't have a, oh, we will bind because it's the local host, but we're not going to be listening on this guy. And we're going to go ahead and we're going to connect to that socket FD, which should be on localhost, port 3000. So we are connected. And then for right now, let's just prove that we established that connection. So I'll recompile the server even though, oh, GCC ChatServer.c. We get that listening, and then we're going to GCC ChatClient.c /a.out. So this guy says we are connected. Over here, did not get connected. All right, so port 3000. Oh, that's not. We need to set up our socket for the client a little differently. Okay. All right, we know the port number, normal socket stream. So here's our we know ours is going to be localhost. We have that, we have that. It should have opened the connection. I think it's this. When we're listening, we need to tell this guy localhost. It's this guy right here that needs to change. I think this should just be localhost. I think it should be able to resolve that. Let's give that the old college try. Oh, it needs to be an integer. Actually, we want socket. Right, we need the out address. So alias. All right, so this guy should get us the. Just have to pass that localhost. And then I could use that to get the H address. All right, the host address. Server is of type. Okay. Set server's value here. That should build the struct for me from that. Let's move that up top here. And then we start setting the information for it. We have a name. Okay. All right, that's the same. So that's just our type of address. Then we'll say server H address. Port is the same. for server address. It has a variable for that up here too. We already have that, don't we? No, we don't. We just didn't name it the same thing. So they're naming it server address, so it'll just match theirs because this is the client talking to, oop, am I in the chat client or chat server? Oop. Get rid of that. Fine, save that. Go back to this, the client. I want those two lines. I put them in the server. I meant to put them in the client. So that'll get our server address. That's our server address. And then we're setting server address down here. It's the same data type as we used in the other one. They just called it something different. So we'll say server address, all that stuff, just like we did before. Port's the same, but we don't have an in address because we're actually making an outward connection. So now we use our server address. It should be the output of host ENT. Somebody's in the server. Oh, it's copying the character string. This guy into okay, we'll just steal it for the sake of time. So we're going to take our host address that came from our server, copy it into the in address from our server address up above here, this guy. And it's going to have the length of whatever our host address is. And these are all things that came from get host by name. They're using this function called bcopy to copy this string into this string. Effectively what it does is it just looks for the \0 to know when the string end is. All right, we already have the port. Now we should be able to connect. All that's being done in terms of so we're not doing that. We're not doing that. Connect. Okay, I think that should build. We're still listening. Oh, I'm still calling it name in there. It's no longer name. It's server whatever. Server address. And then I think it should work. Server address, server address. Okay. Last thing. It's the same thing we had on the other one. All right, I think we're 2 lines of code from our client connecting, and then we should be able to read the stuff back and forth, all to avoid using C strings. All right. So no homework today since you don't have anything to work off of, but you'll have homework over the weekend.